We work, we live, we innovate and create. At the center of it all is your brain health. The ability to solve problems, think analytically, share empathy, and thrive.
We're trying to make brain performance really the next fitness revolution.
So how do you boost brain power? Welcome to the Brain Health Project, an urgent call to transform your mind to work stronger and faster.
This is an absolute crisis as great as any we have ever faced. We have to equip the minds and brains of our citizens to cope with the accelerating, dizzying rate of change that they face in their lives.
Your brain health is not fixed. Scientific discoveries prove it can adapt and grow regardless of your starting point.
Our greatest value, the asset that will help us to change everything, every problem we're in, is all in our head.
To harness that treasure, we must measure and monitor progress while things are going well versus waiting for an injury or disease to strike.
Too many of us are outliving our brains, and that does not have to be the case.
The information age is bombarding us with more content than our human brains can handle. How do you keep from getting lost in this? And focus on deep thinking. For starters, stop multitasking.
Science shows us that multitasking is bad for your brain. It reduces fluid intelligence, causes brain atrophy, and increases chronic stress.
The global pandemic is creating more stress than ever. Stress that leads to depression and anxiety and beyond. Unlocking our potential to navigate these hurdles starts with learning the right strategies, even in school.
So when teachers have these strategies, they're empowered to support our learners, and then the learners are now able to take ownership of their learning.
Training kids how to think is doubling academic achievement among middle schoolers.
I think the greatest national security threat is pre-K through 12. If we don't take care of educating our young men and women, then we have to ask ourselves, where are we going to be in 20 years?
Our world-renowned scientists know you can increase your brain health, not lose it. It's time for a new category of health, brain health. You are a game changer. Ready to transform the world with us? Be a part of the brain health revolution. It starts here.
Welcome to the Frontiers of Brain Health talk series. We're excited to get this fall series going. We've got another great lineup of interesting speakers relevant to brain health. I'm Dan Krauzik. I'm the Deputy Director at the Center for Brain Health. And we have a virtual Q&A session. So if you would like throughout the talk today to use that Q&A function, we will take some of those questions at the end. For those of you unfamiliar with the Center for Brain Health, we are a cognitive neuroscience center dedicated to exploring neuroplasticity. And as part of that mission, we bring in experts from around the world who are quite relevant to that mission. So today's talk will be by Dr. Selena Bartlett, who is from Australia. She got her PhD at the University of Queensland, and she is currently specializing really in addiction, obesity, and health. She's widely published in the peer-reviewed literature. She also is the author of Smashing Mindset, which is a very relevant book related to stress and exercise and healthy brain habits. So we're very excited to hear all of her wisdom. She's also the host of a very thriving podcast called Thriving Minds. So definitely look that up. Lots of great information, and she interviews world experts in the area. So without further ado, let's go ahead and welcome Selena Bartlett.
It's a great honor to be here. And for people that don't know me, I am Australian, but I'm also American. So I spent 12 years in the Bay Area at the University of California, San Francisco. And I'm really honored to be in this amazing building and being within the brain itself. I deliver a brain talk as kind of the highlight of my career, especially at Sandy Chapman's Center for Brain Health. What an amazing experience this has been. And she has really created something that is like beyond my imagination. So the aim, we're trying to get the slides working, but my aim here for you today is to help you understand the latest advances that are beyond even my imagination of studying the brain for a really long time, and to show you that we're in an amazing period in history that we can learn how to empower our own brain. The tagline I like to use, I now do a lot of public speaking, and I have a column in the Australian newspaper that's actually a Murdoch newspaper, and I've actually convinced them this year for the first time, right next to the horoscopes, we now have a column called Brain Health. And that, as you know, and talked to Sandy many times, this is a huge breakthrough because for some unknown reason in this world, we don't want to talk about the brain as something that all of us have and we need to make healthy. So that's been really good. So I'm also run a research lab, and I came in to become a neuroscientist. I was actually a pharmacist in 1989, and my sister actually ended up with a mental illness. She ended up in a lockup ward in Brisbane, and I was with her and my mother, and it was during this time that I discovered that we clearly don't know how the brain works. Because how would you take a little 21-year-old that was really just hearing voices or something not very dramatic and treat her like that? And so in 1989, and my story is not that much dissimilar to Sandy Chapman's story. So in 1989, this is kind of where she was. And so I stopped being a pharmacist. I went back, did my PhD in neuropharmacology, and I've been traveling the world ever since to understand how the brain works at its basic level, but also now at the translational level to improve the lives of people. So yes, I am a neuroscientist and I'm an academic, but I now have a podcast here as well called Thriving Minds, to bring this, because we have these platforms now where we can bring this brain health and fitness message to the world. It's time to democratize the brain to improve the lives of people rather than outsourcing our brain to everyone else that we think is an expert. This is my lab in Brisbane, Australia. So I used to run a lab, and I was actually developing drugs for 20 years, working with Pfizer. I developed varenicline for alcohol addiction, and I ran that lab for 12 years, and then I went back to Australia. It was during my conversion back to Australia and to this amazing Translational Research Institute that I changed my whole research focus from developing medications to neuroplasticity. And it happened because I discovered that sugar is as addictive as alcohol and nicotine, which I'll touch on today. So this is my sister, and this is what made me become a neuroscientist, and this is my sister here. Unfortunately, she passed away, so my lecture today is dedicated to her, and most of my lectures always are, and she's been the reason why I keep going to try and improve and understand how the brain actually works. All my work has been built on the back of many, many people's contributions, so I just want to acknowledge all of these people right now and the funding sources that have allowed all of this research to take place. So, now in 2020, and Sandy is an author on this opinion piece in Molecular Psychiatry, which is one of the top journals, where they talk about a brain capital strategy. And I'm not sure how many people in this room are aware, but they have the OECD now that set up a neuroscience unit because behavioral economics hasn't served us very well. And so clearly understanding the brain is going to be the future. And so this opinion piece is talking about a brain capital strategy, because no one in this room would deny that we're in a brain capital economy. And at the epicenter of that is all of us are using high-level cognitive skills every day You can just think about your phone, for example, and what it takes to like not have a button there anymore and having to learn to scroll up, for example, when you're my age. You know, it takes a bit of cognitive skill development. So outside those simple tasks, most people entering the economy now need optimal brain health. And so this is what the opinion piece is all about. But the reason I got really excited about this, 2020, no one would have ever have written this paper even 5 years ago. The field has massively, exponentially changed. And that's one, because of the pandemic opening a window to say, yes, we all do have a brain, and we all can have things happen to us. But also just because of the STEM technology, the digital technology, and the need to have cognitive skills to participate in this economy is really substantial. So what I like to think about with this information of the things you can do every day to train your brain is like sharing the cheat codes to the good life. And this came about because of this amazing Paralympian called Kurt Burnley. He was the Australian of the Year a couple of years ago. And this is one of my columns that I get to write 500 words. I'm allowed to talk about one thing that the public can do every day for a month. And he joined me on this column and he was on my podcast. What he equates this to is when he was 11 years old, obviously he was born without legs. This is him walking the Kokoda Trail without legs, which is a very difficult track to do. Anyway, when he was 11, he met another person in a wheelchair, and they came up to him and he said, hey, saw off those handles to your wheelchair and get rid of the brakes. And he went home and he did that, and he says that his pathway to independence and athletic prowess that made him become an Olympic champion. And he won many gold medals. And he now trains and helps other Paralympians, and one of them just won many gold medals in London. And so he calls this sharing the cheat codes. This guy that came up to him when he was 11 gave him some cheat codes that meant he didn't have to go through all the same obstacles. Brain health is the same thing. What we're doing today is sharing with you cheat codes that you don't have to keep suffering or trying to work out your own way around this. You can learn from experts and expertise in the field. And we have so many ways of getting that information now that we never used to. So when you woke up this morning, is this how you felt about today? Can't wait to go to that brain health lecture that Sandy's put on.
Yes, they did.
I'm going to learn so much about my brain today, I can't wait. Or is it more like this? Oh my God. Not another thing that I have to go to. Sandy. So when I give these lectures, more or less 90% of my audience feels like this. So when I put that up there because I asked you this question to reflect on, do you know what's happening inside your brain when it's stressed out? Any takers? What do you think is happening in your brain when it's stressed out? What was that?
Sally said she didn't know what's happening.
Too many messages, too
Yes.
worried.
Too many tabs open on the computer? It feels like that. What about the chemicals or the parts of the brain that are being disrupted as a consequence of stress? Has anyone shown you what they are and how you can handle and understand that and do something about it? So that's what today's lecture is going to be about, and I hope that you leave with a few little strategies that can really change your understanding of this. And I want to tell you that I started studying the brain in 1989. I've done everything that you can do in the space, and I didn't think I'd be standing in front of you today, and I started doing this 8 years ago now, because I didn't think that we'd be this far advanced in understanding the brain. I actually was going to give up in 2009 because I didn't think I'd be able to make any more difference, and I've been developing drugs and stuff like that. The neuroimaging technology and the genomics revolution has fundamentally revolutionized our understanding of how the brain works and behavior, and it's not what you read in the textbooks now. The textbooks have not been updated, and it's time that they are, but that takes about 20 years. But podcasts and these platforms and this digitization have allowed us to completely disrupt the field, and it's time for us to now take that and democratize it to the people. And that's what I've been trying to do for a number of, that's why I stepped out of my research lab. I still have my research lab where we do fundamental neuroscience, but I also do a lot of these lectures because I fundamentally changed my own life and wrote these books for the public and have a podcast because I think anyone can do this for themselves and for their family. So how has it changed it? What do you mean? Oh, that's science. How is that going to do anything for me tomorrow? Well, let's just have a look at this. 8,000 years of history, we could never see inside the brain. So people made up a lot of stuff, and they still do. And so, but the beauty of science and technology is that, is it okay? I want to. The beauty is that you can now see the blood flowing inside the brain. You can actually see inside your brain, and in not too long a period of time, each of you will be able to see inside your own brain. And that seeing makes a huge difference because when you go to the gym and you're exercising the muscles in your arms and you do 5 reps, you can see it changing. Or when you start walking to running, you can start to see your muscles toning up. But when it comes to your brain, you can't see it toning up. So you don't think you have to worry about it and you get away with it. But the technology is now allowing us to see that you can train your brain like a muscle. And that's so important. It's such a critical difference in what we could do. Only 8 years ago, we couldn't do that. And so in that image, on the right-hand side, you could see blood flow up on the top-hand side. That's red blood flow happening. Under stress, the first thing that's impacted is a shift to the blood flow leaving the prefrontal cortex area. The prefrontal cortex area is the part that allows us to say no to ourselves, and it's the part that allows us to make decisions, for example. Stress is the thing that impacts that part of the brain first. It's the humanist, it's the newest part of the brain, and it's only been developing really, really recently in history, for example. Most people won't be aware of just how much stress impacts the way their brain works. And each of us exists on a spectrum. This is not a static thing where you have this happening and that's your brain, or you have that side of the image and that's your brain. No, this exists on a spectrum between these things, and it can change during the day. So as an example of that, how do you know if you've got a stressed brain? Someone asked me that on the radio. I said, what are you eating? And they said, what do you mean, what am I eating? So what do you do at 2 o'clock? Do you go to the vending machine? Or do you go to the fridge and look for the chocolate? You know, that kind of thing. That's the way that you know your brain's stressed out, because the brain handles stress by helping you seek these rewards, for example. So while we wait for the slides to come up, let's just do a little test so you can feel your prefrontal cortex. Would anyone like to feel their prefrontal cortex? Okay, so this is called a working memory test. So one of the centers of your brain that's really, really important is called working memory. And this is not just having good memory. This is the part of the brain that allows you to hold pieces of information in before it goes into your hippocampus and gets consolidated into a memory. So it's the thing where you're having to remember a set of numbers, or you're having to remember a list of things. You know, you go to the store and go, what was that thing I had to get again? You go home with only 4 of the 5 items that you were going with. So that's working memory. Working memory is at the epicenter of executive function, which allows us to make short-term decisions and do long-range planning. So this part of the brain can be trained too, like a muscle. And that then extends the onion layers on our prefrontal cortex. So let's just do the working memory test. So I'm going to read out a sequence of numbers. And we all love math, don't we? And then I'm going to give you a math problem, very simple. And then you're going to tell me back the answer. And then you're going to turn to your neighbour and say these numbers in reverse. So you're not allowed to write this down. You're not allowed to use your iPhone. You're not allowed to do anything. It's just we want to test and so you can feel your brain, for example. Because we never feel our brain, do we? Okay, so this is the sequence of numbers. It's 0, 5, 6, 3, 7, 8, 9, 2, And the problem is 99 plus 4 equals, and say it back to me out loud. 3. Great. Now turn to your neighbour and say that first sequence of numbers in reverse.
That's right. 2, 8, 2, 7, 2, 8, 7. So in reverse. Right there with you. Right there. So 05 with you. 07, 0. So you're 6, 5, 3, 7, 9. Yeah. Hell if I know. Okay. There you go. Sarah, you should have been this robust. Wow. Yeah, never. Sorry. Yeah. That's okay. That is exciting. And okay. Well, I'm going to say I failed.
Start. We're a sharing team here. So if you would like to volunteer to start telling us what you think it is. Anyone want to have a go? Someone can just get...
I'll try to end.
Okay.
I think I know what it ends with.
Okay, great.
76530.
No. Good try though.
Christy did it. Christy. Yeah, but I've lost it.
Christy, tell us anyway.
There was a 9 and a 2. 0. 6, 5. No, 3, 5, 0. I got that end part.
Yes, not too bad at all.
I don't know.
Say it again.
987.
Close. Okay, so it's 2, 9, 8, 7, 3, 6, 5, 0. So what I did was, don't feel bad about this. I stressed out your brain on purpose. I wanted to show you what happens when I move your blood flow out of your prefrontal cortex. So I did that by saying, this is a math problem. And so immediately, there's 3 responses to that always. Oh, I'm really good at math, no worries. So take a deep breath, I'll hear what she says, no problem. Or there's the, can't do math, I'm not even going to try. And there's the one like, why is she making that do this to me? I'm really angry at her. And then there's the people, I just might go to the bathroom right now. So basically, what's happening is that, like, when I mention all these words, I'm doing it on purpose, specifically because I want you to feel what it's like to put your brain under stress on purpose. And then I totally disrupted your working memory. And what I meant by that is I took out those physical connections in your brain to take in the information. So the people that could do it are the people that were not letting that happen. They're taking deep breath, they're putting their shoulders back, they're keeping the blood flow in the prefrontal cortex. Because without the blood flow and the oxygen, the working memory center of the brain can't work. So can you think of how many people have this happening to them all the time, every day, when they see a set of emails coming at them, or that someone looks at them in a funny way, or I can give you a million examples of how the blood flow disappears from that part of the brain and disrupts our ability to pay attention, to think that we can do something, and all of these different consequences. And so this first book I wrote called Miggy Matters is to describe why that is. And in here you'll see a koala who's really calm. And then you'll see a monster, which I called Miggy Monster, and I made it all in colour and everything to teach people about this one little item about the brain, about how important stress is and how to manage stress so you can keep your brain really healthy. And the funny thing is about this, and I think there's some copies here for people to take from this presentation. The funny thing about this is when I did this illustration with someone from Florida who helped me, turns out the koala is calm because it's sucking on gum leaves and it's actually high. And I had no idea that that's why they're so calm. So, and I'm an addiction neuroscientist. That's your prize for trying. Anyway, so neuroscience has really fundamentally changed, and it's really every day something new coming out, and I'm posting on this all the time because the changes in the science are so huge. And we can now map every cell in the brain genomically with technology. It's not just epigenetics now, we understand so much more. So, I don't know if I can, oh, there we go. So let's just get into this now. We're not born a blank slate. You weren't born the day you were born in terms of the way the brain is functioning. And the other important point is that the brain has a great capacity for change, and most people are only tapping into a very small percentage of their potential. The brain is definitely at least 40% of untapped potential. And the really curious thing about this is it's not what you can see, it's what you can't see, is where the potential is. And so why the changes are so hard to make is because you have to drive the changes to create new synapses. And I love this. This is the best thing ever. So you can see it lighting up here, and this is such a great example of what I mean. So you can see the ones that are lit up, they're already formed, but what we're trying to do is create new ones, and that takes a lot of hard work. And we always give up about day 3 into it. So these concepts of neuroplasticity, it's our fault as neuroscientists telling you can't change your brain. So we said that you could up until age 25, but then it's like a fall, after that it's all over, red rover. And that was really, really wrong. And you can blame the visual neuroscientists for that. Because they were the first ones to map the circuit to the visual system, which was very direct and specific and very labelled. And then we just did that for the rest of the brain. And so that's where we went really wrong. When I show you this picture, you would immediately say, yeah, neuroplasticity. Of course the brain's plastic. You know, you look at these young brains, these two little twins, and they just grow and develop. And you know that there's a huge amount of brain plasticity happening. And in fact, these newborn brains just recently have been published in a really good journal, and they could image the brain of 267 newborn babies up to the age of 10. And what they were able to show is that the only part of the brain that's active in a newborn brain is the attention circuit. And why would that be? Because the babies have to get attention from the adults to be fed, to get shelter and all of those things. So those networks are really, really strong. Babies can't self-regulate. So those networks of self-regulation are not present. So that's why we know for sure that the attention networks and the strength of this part of your brain is highly dependent upon the proximity of caretaking you were given between the ages of 0 and 3. And your mothers and fathers as well. And their parents. So this is a multi-generational thing that's happening. And the way that brain health originally formed and the strength of your own brain health across your lifespan is highly dependent on the proximity of caretaking you were given between 0 and 3. And this is obvious, isn't it? You can look at all the statistics to show that people that come from loving, supportive homes that have everything and go on to be really successful mostly, compared to people that are given nothing in the beginning. So we know that poverty, incarceration, and all of these other factors serve heavily to see a brain that's born with genius inside it doesn't ever get to capitalize, or very rarely gets to capitalize and leverage on their geniusness, just related to the fact of being born into poverty, for example. So why is all of this? So we talk about humans, but rarely do we think about where our brains came from. So our brain architecture and my ability to stress out your brain in a millisecond came because of that circuit I tapped into a circuit on purpose. It goes back in time over a really long period of history because its main job is to keep you alive and safe. It's a strong circuit, it's really, really hardwired into your brain, and it comes back for a long period of time. So let me give you another example of what that looks like. I don't know how many of you have seen this video. Let's see if we can play it. Yeah. There you go. guess what's happening?
I think it's a snake.
Yes, that's right.
What do you think, Sarah?
So you can see the reaction. So it's not all your cats, by the way. Like all your cats are in loving homes. So it's not every cat's brain that's going to do this. So many people watch this and go home and try and do it with their cat and go, oh, it didn't work. And I say, well, you've got a loving home, haven't you? So what's happening there is that circuit that's allowing the cat within milliseconds, by just turning and seeing a shape, has already activated all the neural circuits to escape, right, away from it, because it's immediately thinking it's a threat. So think about that with your emails, right? It's the same thing happening. You know, when I stressed out your brain, I just tapped into that circuit. And I did that in a millisecond. So that circuit is so fine-tuned, so hardwired. It's so important for our survival. It's a really, really, really important circuit. Because when you're jumping out in the road and the car's coming, you've got to get out in milliseconds. You can't wait and see, oh, maybe it'll stop. That kind of thing. So but the cool thing, and why I wrote MIDI Matters, is because MIDI is the problem, it's also the solution, because in a human brain, what do we show you? The prefrontal cortex, the executive function networks, humans can access them consciously, whereas the cat can't. So if you've got a stressed out cat, it's always going to jump like that. It's not going to take a deep breath, put its arms on its shoulder and go, just a cucumber. I'm going to walk around it. Humans can do that, but we don't really, do we? Because we're so attached to identifying everything as being, you know, a stream of emails, oh my God, I'm so stressed out, and we react like that, and we shut down our working memory, we shut down our attention, we're on our phone, we're on our computer, we're doing all of those things, and we're actually stressing out our brain without even realizing it. So the moral of this story is your boss is a cucumber. Sandy, sorry. Sandy's one person I can do this in front of. Yeah, I'm not trying to be funny, but you know, you have to make people laugh, because the best medicine obviously to get into good neuroplasticity. So this is just another example of what we now show through all the science. It's just amazing to be a neuroscientist in this era. I never thought this would be the case. The advances are extreme and daily, and it's just amazing to be part of it, isn't it? What we can do now we could never do before. Poor brain health. So this is why most people are suffering with poor brain health, is because of not understanding that the brain's like a muscle that needs to be trained like a muscle, and it's got to be trained across your lifespan as a muscle that needs toning and strengthening. You've got to build layers on this onion peel of immenseness. It's a supercomputer. And if it's not treated like one, it plays up big time. And some of these examples you can think about for yourself. Like, I can tell you now, after having COVID this year, that I affected my memory. And I could feel my working memory was affected, so I had to go and do more brain training to make my memory get better again. So just small examples of that. But how you can tell if you're starting to have some poor brain health is by thinking about if you can't focus on something, you're easily distracted. That's your attention networks. And working memory, like if I can stress out your brain, you can see why we need to train the way stress enters our brain. And we can do that through very specific strategies, which I'll talk about soon. We just did the working memory test. I just moved it up so you could, and it actually worked out better because you could see the brain imaging. So the science, so I went in this because my sister had a mental illness and I didn't like how she was treated. And so I developed drugs. I went straight into the brain looking at mutating amino acids, and I still do some of that. But what's come out through the neuroimaging work and the genomics technology work is that there's a common neurobiological substrate that underpins all mental disorders, including schizophrenia, bipolar, depression, addiction, obsessive compulsive disorder, and anxiety. And that's through a meta-analysis of 193 studies with 16,000 people doing some brain imaging work, demonstrating a deficit in executive function and decision making as being a common neurobiological impact, and you can see that in any of these different disorders, right? We know that part of the brain can be trained, like a muscle. And so this is why we do what we do and why we're so passionate about it. And the science is out now showing it. So therefore, why did my sister get a mental illness? And why did not I? I might have one actually after this talk. We are on a spectrum. We are on a spectrum. But these are the questions I went looking for, and etc. And what I discovered wasn't what I wanted to find, but I discovered it is in my family, and the reasons why. And this pertains now to most mental illnesses. We now understand where they come from. And like everything, we're always treating the symptoms and the disorder rather than the cause, and making those changes down here at the cause. And these are the bits we don't like to talk about. And that's why Sandy and I are really interested in promoting brain health and neuroplasticity and the strength and resilience part of it. And I think that is the future. But just for anyone that's curious to know why do we have so many mental illnesses and why they're escalating, and that's partly because of many factors, and I'm just going to give you 3 of those factors, and it's complicated and we keep learning new things. But adverse childhood experiences, this is the work of Ender and Folletti from 1986 in Kaiser Permanente, and the CDC did this amazing work. It was an obesity weight loss study, and they were trying to help people lose weight, and they were being really successful. And then people started dropping out as they lost a lot of weight, and they went and interviewed them and said, why are you dropping out? And they said, well, because now you're making me deal with the reason that I was eating in the first place. And they said, what do you mean? And they said they talk about the adverse childhood experiences they had, and that was why they were eating. And so they reframed the whole study, and now this has been replicated in thousands of papers around the world over the last 25 years, demonstrating that depending on the amount of adverse childhood experiences you'd had, then the susceptibility, meaning the genetic expression of your disease, which then affects your circuits, then contributes to the expression of, say, schizophrenia when you're 18 plus, or bipolar, or addiction, etc. Addiction, by the way, because now I've studied it for so long, is simply medication for stress. So I'll let you process that. But and we're always looking at the alcohol, the sugar, but addiction is actually medication for stress. And I can tell you that unequivocally. So this study was really a breakthrough study. Now the Surgeon General of California, Nadine Burke, has an ACEs survey that everyone has to do when they enter hospital, etc. But this is not to make you sad and think it's all over Red Rover. This is just science. It's an understanding which now we can make change and do things differently. And it's not just about the individual experiences, which the survey looks at, but there's also many other adverse community events that happen, like COVID lockdown. That had an impact differently for different people, and all of these other factors. So I like this slide because it's like a tree, right? It looks like the brain. And so how to think about this is all these roots in the tree are like synapses that we have above us. And each little experience because the brain likes to take in negative experiences over positive experiences, as you just learned, I could stress out your brain in milliseconds. That's how susceptible the prefrontal cortex is to stress. So you can imagine how these events then impact the architecture of the brain and the circuitry of the brain. It has a dramatic impact. So what that means, therefore, is that this brain then struggles to have really good attention or working memory or all these executive functions we always measure. And then this is now multi-generational. So we now have evidence. You've heard of genetics, which is your blueprint, and epigenetics is how your environment changes the way your genes are expressed. Well, we now know that 3 generations back, it's also microRNAs. So microRNAs hold memories, and those memories are passed on for 3 generations. And that's why you see survivors of people that went through the Holocaust, 3 generations on, never seeing the Holocaust, but maintaining some aspects in their brain architecture as if they had experienced the Holocaust. So that's an extreme example.
Are you talking about physical versus having heard about it? That
yes.
Almost like genetically?
Yes, genetically. So microRNAs are like So you have your DNA, which you get sequenced if you do 23andMe, and then you have methylation sequences around those genes, which then dictate which genes get expressed, which is why each of us is so different, architecturally different. And then microRNAs have just been discovered in the last 3 or 4 years, and they're then also going into the synaptic component, and our synapses are our memory depots. If you think about your memories, right? So there's many memories we don't even know that we've inherited, for example. And this is all very new work. It's called transgenerational epigenetic inheritance. So this is really in the last, let's say, 5 years of research that's really becoming really big, because we can sequence everything now using the technology. So this was an eye-opener for me, and it completely changed all my research. I completely changed my lab. I re-geared into neuroplasticity. I worked out everything I needed to work out, and now you'll see here, because I was an alcohol addiction neuroscientist at the Gallo Center at UCSF for 12 years, developing drugs for alcohol addiction. Then I worked out I was developing drugs for a medication, if you know what I mean. So then I went, well, I got that wrong. So now it took me 3 years to everything I do, I get wrong. I have to go back and start all over again. So alcohol addiction, here you can see here the ACE score, Adverse Childhood Experience Score, is a complete dictator of whether someone goes on to develop alcoholism. 80% of IV drug use in women is attributed to adverse childhood experiences. But that's not to make you sad, because this is built off the background of generations of evolution of resilience. Because we're here today, aren't we? We've been evolving for millions of years. And so even though these things do happen, we're still very resilient people. So I had my genome sequenced, this is me, and I discovered I'm Scottish. Doesn't like the Scots because he's English. You should have told me that before we got married. But the Scottish people, my mother's very strong and resilient. Her mother was very strong and resilient. So I have built in me this, and each of you do as well. So this is to give you the wide perspective. So I showed you some of the reasons, but then to take back and move into strength and resilience, you have to step back and think we are really strong and resilient. So how do we tap into that network to drive the brain in the direction as a supercomputer it really wants to go? Because the difference between animals and humans is that we can do that. We know how to do that. We can tap into these really strong, resilient networks. All of us can do that. That's what my lab now does, and that's my complete focus. So how do we reboot neuroplasticity for people that have an alcoholic brain, for example? How do we promote resilience? And this is what the whole aim of the Centre for Brain Health is as well. And so this is, I take many approaches. As you know, I'm a medically trained neuroscientist. So we do a lot of neurogenesis work. So we actually look at new brain cells. And we just, this is a publication. I'm not going to go into details, but just to say to you, we found a drug that can actually reboot an alcoholic brain and develop new brain cells from. And obviously these are animal studies, but this drug was an anti-anxiety drug that we were able to repurpose. And this is one of the papers that we published from. So that's taking a very much a neuroscience approach to understanding the question, is it possible to reboot new brain cells from people? So this is an alcoholic brain. Sugar does exactly the same thing to the brain that alcohol does as well. Sorry about that. Whenever I go into a room, people put down their cookie, and it's really annoying.
But you say that because it does make people instantly go, how much sugar are you talking about?
So
just having a cookie.
That's a great question, thank you. And so what happened was I was doing my alcohols research, and we're using sugar as the controls. So the World Health Organization's just come out and completely reduced the guidelines. So now it's 9 teaspoons a day for men, 6 teaspoons a day for women, and 5 teaspoons a day for children. And a can of Coke, as an example, has about 30 teaspoons of sugar in it. And the other thing that's happened, and there's a whole movement around America driven by Robert Lustig, who I used to work with at UCSF, where they've shown that processed food And this happened to me. I had to get rid of sugar out of my life because that was my medication for all my stress. And what they've shown is that sugar, like if you had bread, you'll feel sweetness. So they've put high fructose corn syrup and sugar in many foods. And so it's not just the lollies and the cookies, it's actually becoming aware that sugar is actually embedded in all the food. And that was a bit of a shock to me as well when I discovered that finding. So what we discovered was that sugar activates nicotine receptors in the brain the same way nicotine does. And then we showed it changes the physical structure of the brain, the executive network, in the same way that alcohol does as well. So we didn't expect that because it was a control in our studies. So, so let's just switch to neuroplasticity and training the brain like a muscle. Think of the brain like a supercomputer that needs, and this is what I used to use in 1989 when I was doing my honours degree, but this is what I use now. Think of your brain the same way. And become curious about your brain, like just how much more it can do than you realize it can do. And that questioning, that curiosity, becoming open-minded about it is the hardest step. Because most people feel stuck, this is what my uncle did, this is what I do, and they think that they're a certain way. And I was like that too. And it was that big change and moving from developing drugs to doing this new work that completely changed my life. Because I never used to have blonde hair either. Change that too. So anyone can do this. Anyone across their lifespan. A 92-year-old just finished a triathlon in Milwaukee. There's 105-year-olds doing triathlons. So what are some of the simple things that you can do tomorrow morning? And the one that people love the most, and this made a huge difference to my life, was changing up the morning routine. So I don't know what the first thing you do is as soon as you open your eyes. Like as soon as you open your eyes in the morning, what do you do?
Meditate.
Phone, emails, the news, oh my God. So remember what I showed you when I asked you to do a math test? Well, that's doing exactly the same thing to the brain. So when we open our eyes, I challenge you tomorrow to just look out the window and take a really panoramic, wide view outside the window and think of 3 things that you're grateful for, or things that are great, or people that you think might be grateful for what you've done for them. I challenge you to do that, and I ask you to do that repeatedly for the rest of the year. So what you'll find is, you'll do it tomorrow, you'll be really excited, but by day 3 you'll be back to your phone reviews. So the reason we like doing that is because it teaches you that if you can't do a change in your morning routine continuously for the rest of the year, you can't change your life. You know what I mean? It's hard to change up your whole life. Because the brain, to get these new synapses, when you make that change, and I'm going to show you the science behind why the panoramic visual view changes your autonomic nervous system in the next slide. But basically, it teaches you that the brain needs a lot of repetitive change every day to get that new synapse, because you're making new circuits, like you're creating new proteins. Those little things that light up only light up after they've been done for a long period of time, the same thing over and over again. And you hear this all the time, the habit takes blah, 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 to form, but every brain is different. So I can give you the morning routine. Some people might be already doing that, so therefore you need to do something new. The brain needs tons of novelty, especially across the lifespan. You've got to do something new. So the people living the longest, free of chronic diseases, are doing new things every decade, all the time. They're learning fencing in their 80s, or they're riding their bike, they're gardening, they're with people, they're learning new things. So I think you call this, Sandy, what do you call it, 7 new things as part of your 2 + 5 + 7 strategies. And that's so important because that novelty is what the brain, because it's a supercomputer, and if you don't give it to it, it just stops working. And then the more you leave it stopped working, the harder it is to then get going again, which is why everyone's so different at making these changes. Another one that and so these things are just little things to try, because if you can't do the little things, don't bother signing up to a 15-week course, or, you know, that's what I say, just don't worry about it, you know. You've got to do the small things first, and they make all the change, and then you get your confidence, like, wow, I didn't know I could do that. Oh, I'm feeling so much better. I did that for myself. I'm empowering my own brain. What else can I do? It's amazing. That's what happened to me anyway. That's why I got into all of these extreme neuroplasticity people. And one of them is Wim Hof. So this is the cold showers. You go to say to me, what do you mean having a cold shower? Well, Dallas it's pretty hard to have a cold shower, isn't it? But in London it was pretty good. No, Sweden. But anyway, so the cold shower works because it actually changes the brainstem, which is this connection between your spinal cord and the top part of your brain. And I'll just go quickly. I want to show you that. So what it does is it actually changes and activates the periaqueductal grey area of your brain, which is where analgesia happens. So when you take Panadol or you take morphine, for example, to relieve pain, there's a center in your brain that's activating. And the cold shower does something similar. So they've imaged the person that there's a number of people that did this, but Wim Hof is one of them. And I did a podcast with a person that imaged his brain, and they've basically shown that he's retrained his brainstem, this part of your brain, which we thought was automatic. We called it the autonomic nervous system that controls your breathing and your heart rate and your immune system. Guess what? It's changeable. So we've got there is no such thing as the autonomic nervous system. So we teach the sympathetic nervous system, we teach the autonomic nervous system still, but that is a changeable, it's plastic and it can be trained like a muscle, and I just challenge you to try it. So if you like hot showers, you're the perfect candidate for this. If you like cold showers, don't bother. Do the morning routine instead. And I could go into details about that, but I want to keep going. The other thing is value of kindness at work and serve and return relationships. That's where the proximity of caretaking comes in, because the social connection, our brain is built for social connection. And in fact, when we isolate ourselves and start to move away from people because we're not feeling good or for lots and lots of reasons, it actually activates that stressed part of the brain and causes social anxiety. And so building back those connections, which is not easy for everybody, is critical for brain health and fitness. And I interviewed Randolph Ness, who's the founder and pioneer. He established all the anxiety clinics in America, and he's now at Arizona State University. And we did a podcast about this, so he's also a psychiatrist, talking about the impact and importance of social connection to relieve social anxiety. So I just talked a little bit about that. I'm going to skip over that. You're welcome to take a couple of the books if there's some available for you. The most important thing is you can't change something you can't measure. So we can now measure executive function. We do that a lot in organizations and schools now. So this is the difference. And Sandy and the people here at the Centre for Brain Health talk about the Brain Health Index. And that's really important because you need to know where you're starting from so that you know when you're doing these changes, you can see a change. For example, I like to think about stepping on the scales. And Selena, people hate stepping on the scales. But, I do too. But you can get, it's just like a snapshot because these things move around. They're not static because, if you have a bad day, that these kind of measurements will change, for example. But isn't it great to know how your executive function is? This is like going to the doctor, getting your blood pressure, your cholesterol. Like, isn't this something that should be just, like our brain is the most important organ we have in our body. And this is an example of some data we collected across the high-performing CEOs and leaders of organization, showing you the individual differences between individual executive functions across people that have high jobs, homes, and everything. And you can see just the difference between people. So that's why it's so critically important in the brain health space that we're personalizing and customizing everything, because you can't apply one strategy to a whole organization. That's why meditation only works for a certain number of people, or why a working memory training only works for certain people, because some people already have excellent working memory. So you don't want them doing stuff that they're already good at. We've got to be working on things that we need to bolster so that we can get optimal brain health. And this is something that we're working on publishing. But the reason why is because all those factors I've just already alluded to, genetics, environment, and experience, shape our brain architecture, and our pathways and circuits are individual and different. And that's why kids in this classroom of 28 can't learn the same curriculum, which we force them to and sit. Some people can't sit to learn, for example. And this is where we're heading in the brain health world and fitness world. We're heading to this idea and understanding of, one, without understanding how your own brain works, you can never be compassionate to understanding how another works. The one thing we all have in common is our ability to reboot, reset, recharge, and tap into neuroplasticity. It's just that everyone is different. When you do your morning routine, the reason taking a panoramic view works, and this is the work of Andrew Huberman's lab at Stanford, and he has an amazing podcast I recommend you listen to. And what he's shown, because he's a visual neuroscientist, he was trained at Berkeley, what he's shown is that when you take the wide view, there's a direct pathway or neural circuit that goes directly to the brainstem and to the amygdala, and it decreases the autonomic nervous system activation. So taking a wide view actually decreases the way that your stress system works. So it's an easy way in. So if you're feeling stressed during the day, I recommend just going outside and taking a wide view. When we take the narrow view, I mean honing in on something, whether it's social media or news or anything, it's the opposite. It activates the autonomic nervous system. So when we come up with the morning routine and this idea, it's because it's coming from a place that's based in deep neuroscience understanding now of how these circuits are interconnected, because we can map them now for the first time. It's just so exciting to do that. So, and then by assessing and changing and knowing that you're practicing this every day, and then noticing in yourself whether there's a change taking place. This is the Iceman. You probably have heard about him. This is his brain being imaged, and I talked a little bit about that. This is an image of his brain demonstrating that he can actually consciously change his body temperature. He can also consciously, with other people, there's many scientific papers, he can actually tap into his immune system. And him and 40 other medical students in the Netherlands were injected with endotoxins, and their body didn't respond to them. And this is in a scientific paper that I'm happy to share with you. So there's so much change that's underway in science. There's all these unknowns that we don't know yet. As I said to you, as soon as I think I know something that's wrong. So these are the things that you can make choices of how to tap into neuroplasticity. Thinking of your brain like a muscle is a big one first. How many reps am I going to do today just to train my brain? I'm going to do a morning routine. I'm going to get up and exercise, go out into nature, or do these other strategies. I mentioned a lot about food. Food is a really big poison to the brain. It can be healthy or unhealthy. And becoming aware of what you're eating and when you're eating it. So for example, before I had a meeting with my boss I won't name names, at UCSF, it's much healthier here, isn't it, in Dallas? I'd go to the vending machine and pick up my favorite snack. This is before I knew any of this. And that's when I became really unhealthy over time, because that's how I was getting rid of my stress. Or I'd be raising my kids at home, and I'd get home and cook dinner and write my grant and everything, and then I'd have a glass of wine, and then I'd have 2 glasses of wine, and this is how I was managing my stress in 2008 to 2012-ish. So, and I was completely unaware that sugar was having this impact to make me more stressed and going into my body, because the way fructose goes into the body, the body can't handle it. So it creates fat cells, which are called visceral fat cells, which we're not meant to have, but the body's really good at dealing with us. And so they fill up, basically. And then to get rid of them, you have to exercise like 4,000 times more than you think you should, for example. So our hope and want for everyone is to be happy, healthy, and strong. And that's our message here, I think, at the Centre for Brain Health, in general, for us trying to deliver brain health to the world, is that we believe, and Wim Hof uses this phrase a lot too, everyone deserves an opportunity to be happy, healthy, and strong, and the brain is a great way to learn how to do that, and everyone should get the cheat codes, but they're right there waiting for you to grab. It's all about mindset. Mindset is everything. And mindset's such a funny word. I always think about brain power, but people like this word mindset because literally we just came from London. Martin's dad just turned 90, and we had a big party, 70 people, all his grandchildren came, everyone from around the world. He, 5 years ago, wasn't going to leave a hospital. He had cancer and heart disease and diabetes and all of that. And here he was standing up in front at 90 with his giving an ode to 70 people. Then go to another situation, we go and visit someone in hospital and they don't want to get out of bed and they've only got one sort of cancer but they don't want to be treated. So that's two different mindsets of living and wanting to live well. And Aaliyah Crum has this beautiful TED talk demonstrating that when you tell people that your exercise is good for you and that your work is giving you exercise, it completely changes people's ability to lose weight. So she did this amazing study about mindset and exercise and people that are cleaning hotel rooms. They didn't realize that the exercise that they were doing was good for them. So they did an experiment, a controlled trial experiment, and giving them evidence of why their exercise was good for them, like showing them the calories they were burning from vacuuming and changing linen and all of these different things. And she published this paper called Mindset Matters, and the shocking finding was just by telling them that their work was good exercise, they actually lost weight compared to the group that didn't know they just thought they were doing that for a living. So basically the way you're setting up your mind and brain changes the way your body reacts in consequence. So this was a work out of Stanford not that long ago. So your work can be good exercise, and what you do and how you set your mind is everything. And being open and curious to what can you achieve? How can I tap into this neuroplasticity people keep banging on about? For example, right? Because you don't think that. You think it's for someone else. And when we first gave these talks 8 years ago, people would come up to me, can you go and see my uncle? He's really annoying, he needs you. Or can you go and see my mother or my father or my sister and brother? This went on and on and on. And I'm like, no, I'm obviously not delivering the message. This is about your brain. Because when you develop your brain, everyone copies you because of mirror neurons. Because mirror neurons developed 40,000 years ago. That's how we learned to speak, was by copying each other. So people copy what you do. So if you want different outcomes, if you make the change, it mirrors like a pebble across the lake. So I just want to get to a close here to say that there's this amazing book called The Happiest Man on Earth, that he ended up in Sydney, Australia, but he was in the Holocaust. And he wrote this book, he's 100, he published this book when he was 100. Unfortunately, he passed away just afterwards, but he didn't want to talk about any of the things he suffered, but he survived the Holocaust. And he talks a lot about in his book, The Happiest Man on Earth, Eddie Jaku. Highly recommend it, it's an audio book too. And what he talks about is 3 things that he recommends people think about. Being kind, developing a skill set, because the reason why he didn't get, his family got incinerated, but he didn't, and that's because he got filed into the camp that had, because he had skills that were engineering skills, and they needed those. So as people would go down lines, he got moved always to the right because of his skill set. So learning, he talked a lot about learning and building your skills and how that's really, really, really good for your brain, keeping your brain really strong. And then he talks always about being kind no matter what someone does to you, so you don't end up focusing on the people that did stuff to you, but you focus on always being kind back. So he's always kind, even though people were doing this to him in the camp, he still was always kind, which kept him alive. These are just some things he talks about, but I think about it from a brain plasticity point of view. And then he said, be happy no matter what. So no matter what adversity, because we've all had them, and we will always have adversity because we're humans evolving over millions of years, which means we're actually incredibly strong. And when we start to move our mindset towards our strength and resilience rather than our problems and the issues and the people that are causing them to us, it completely shifts your life. So he lived to 101 and moved to Sydney with his wife and created a lovely construction business and everything. But he calls himself the happiest man on earth. So I think that's a really great way to reflect on if someone can do something like that. And this is not just one-off. I can give you hundreds of millions of examples of people doing the same thing. But it's a great way to think about your brain. That's what he did for his brain, and each of us have the same capacity, and we're not in the Holocaust right now, for example. So as we think about brain fit, brain healthy societies, what we're aiming for is that brain health should be everybody's business. It shouldn't be just experts. It's everyone has a brain. Every child needs the best start in life, and they have a brain that can be trained, and we have to help the parents and society and change the conversation from mental health, illness, and disease to brain health, fitness, resilience, and beauty, and lifespan and health span, rather than being always about the negative. And I think our aim here really is to think about when you're at Thanksgiving and you're saying to your friends and family, so what are you doing for your brain health? You know, because like we talk about yoga, okay, now. We didn't once, like, no way, yoga, that's Eastern, you know? But now everyone has a bottle and a mat and a studio. And like, when I think about, isn't this the most important thing that we should all be doing when we've got dementia and all of these diseases that can be they are preventable. Chronic diseases are preventable diseases through right strategies and things like that. And yes, there are a lot of diseases that are genetic and incurable, and cancers and things like that. So don't get me wrong. There is a middle way. We do need drugs. We need everything. But there's also this emphasis that we need to shift in society, which is why we're really proud to say we have a brain health column going out to in a Murdoch newspaper into millions of people. So this is our aim, is to create brain fit, healthy societies, making brain health everyone's business, helping people understand when you see bad behavior, it's probably most likely because of poor brain health. And that's a big switch. It's hard to do, and because we're so used to don't reward bad behavior, that this is something we like to focus on in schools. Thriving schools is to help teachers see why people are behaving badly, and to start thinking about how can I build the brain health of that child so that then maybe that might then improve their behavior, for example. And we think that everyone, as the science is getting so good, and we need the capability and organisations and schools to focus on this. These strategies can be taught to everybody. You don't need to be an expert to deliver this. So thank you for listening, and thank you for hosting.
Okay, thank you so much, Selena. I think we'll go ahead and wrap up now. I would say maybe if you had questions, we could go with you after the session here. If you have other questions that occur to you, Selena's not at all hard to find. Definitely check out her Thriving Minds podcast, and you can certainly engage with her in the future. We encourage you to do so. Thanks so much for the talk and all the fantastic information.
Thank you for having me.